In this video, we are going to discuss about the three-phase circuits. So, what is a three-phase circuits? The three-phase circuits comes under the polyphase circuits. Polyphase in a sense many. So here, in three-phase circuits, we have three voltages which are same in amplitude and even the phase difference are same. That we are going to discuss in this. So these are the certain loads which requires polyphase supply. As I said, three phase comes under polyphase, which is many phases. Each phases that induces the EMF, which is equal in amplitude and even phase differences. So there are three phases: ER, EY and EB in three phase circuits. And generally the phase difference can be calculated by the 360 degree by n, this formula. So n is nothing but the number of phase. If the number of phase are 3, then 360 degree divided by 3 is 120. Means each phase will have a phase difference of 120 degree. So that is mentioned over here. So three phases: ER, EY and EB. And the first which is the voltage EM sin omega t, and the next voltage EMF induced will have 120 degree phase difference, then that is written as EM sin omega t minus 120, and next is EM sin omega t minus 240, or even we can write it as EM sin omega t plus 120 degree. So three phases which are equal in amplitude and the phase difference is also same, 120 degree. So we say this as a balanced circuit. If all the voltages are same and if it is having the equal phase difference of 120 degree, then we say it as a balanced circuit. So here ER, which is 0 degree, and next EY comes. EY lags ER by 120 degree and EB lags ER by 120 and EY by 240. And here there are two connections: star connections and delta connection. So in star connection we have three lines: R, Y and B. R, Y and B. In addition to this, there is a neutral. So in this star connection, there is no derivation which is given, which is mentioned in the syllabus. There is no derivation, just we have to discuss only about the relationship between the line and phase voltages and currents. So here in star connection, three lines are there: R, Y, B, and one neutral is there. It's a central point. And the connection, how the three phases are connected, how the R, Y, B are connected. It is connected to the neutral, and the same ends are connected to the neutral. For example, see in this R phase, this end is R1 and this end is R2. And here in the second phase, Y1 and Y2, and this is the third phase, which is B1 and B2. So if we see the neutral point is connected to the same ends of the phases like R2, Y2 and B2, or even it can be connected as R1, Y1 and B1. Means same ends are connected together to the central point called the neutral points. So here in this star connection and delta connections, we have to find the relation or concepts of line voltages and line current, and phase voltages and phase currents. So here this is about the circuit diagram, and here how to represent those currents and voltages. So here, as I said, this is one line which is called as R line, and this is Y line, and this is B line. Okay, so current through this line is a line current, which is IR, IY and IB. So the line currents are IR, IY and IB. And what about line voltages? Line voltages, in a sense, voltages between lines. So if we consider the R and Y, the first two lines, the voltage between the line voltages are the voltages between the lines. So first, if we consider R and Y, the voltage between R and Y is VRY. And next, if we consider Y and B, then voltage between that is considered as VYB. And next is voltages between the third and first line, which is B and R. B and R, the voltage between the B and R line is a line voltages. So the line voltages are VRY, VYB and VBR. So this is a line current and this is a line voltages. And next, same what is phase voltage and phase current. So we have to list it first, and next we have to check what is the relation between those lines and phase, current and as well as voltages. So next is this two is about the this two are regarding the lines. Okay, line. And next we'll see the phase, which is phase current and phase voltages. So what is it, phase current? The current through the phases. How many phases are there? There are three phases, R, Y and B. So what is the current through the R phase? R phase is I, R, and Y phase is I, Y, and B phase is I, B. So phase current is nothing but the current through the phases. There are three phases, R, Y, B, so we can write it as IR, IY and IB. And next, what is the voltage? Phase voltages. The phase voltages. So what is the phase voltages? We have three phases, right? R, Y and B. So R1, Y1, B1, R2, Y2 and B2. How it is connected? All are connected to the central point called neutral. Means the phases are connected between the line and neutral. Right? The phases are connected between line and neutral. So what is it? Phase voltages are. So first phase is R phase, where the voltages between that is VRN. And next phase, which is Y phase, where the voltage is VYN. And next is B phase, that third phase, which is connected between B and neutral. So these are all the concepts between the phase current and the phase voltages. So now we'll see what is the relation between these two, means the line and phase. So if we see this list where the line current and phase current, the parameters are same. See the line current, which is IR, IY, IB, and the phase currents are also IR, IY, IB. So we can say the line current equal to phase current. So how to represent this? Current is I and the suffix is L, and current is I, the suffix is I phase. So relation between the line and phase current, which is IL equal to I phase. Okay, IL equal to I phase. Next, what is remaining? We have to find the relation between the line voltages and the phase voltages. Line voltages, which are VRY, VYB and VBR. Phase voltages are VRN, VYN and VBN. Actually, there is a derivation, but derivations are not needed as per the syllabus. So we can directly remember what is the relation between VL and V phase. Okay, IL is equal to I phase. What about VL and V phase? VL equal to root 3 times V phase. And there is one vector diagram here. So this is a vector diagram. So this vector diagram gives you the relation between the line voltage and the phase voltage. So if you see this, we have to draw a vector diagram which is having 120-degree phase differences. 120-degree phase differences. Okay, it should be equal. The amplitude and even the phase difference should be same. And next we are writing this as a line voltages, which is VR, and here it is a VY, and here it is a VB. Okay, it says VR, VY and VB. And next, two line voltages gives one phase voltages. So VR and VY gives you VRY. So actually there is a derivation, but no need to worry about the derivations. Just remember the formula. We can identify which IL equal to I phase. So the another formula VL will be root 3 into V phase. That's it. And remember the vector diagram. This is about the relation between the line and phase voltages in the star connections. IL equal to I phase, VL equal to root 3 into V phase. That's it about the star connection. And power, even the power is there. In a single phase, power is VLIL cos phi. Here in three phase, it is root 3 VLIL cos phi, and the unit is watts. Next is about the delta connection. Delta connection, even here there are three phases because we are discussing about three phase AC circuits. So three phases, which is R, Y and B. So how these three phases are connected? Previously, the same ends are connected to the neutral point. Here, if we see the R and Y, how it is connected, R2 is connected with the Y1. The similar ends are connected here. And Y2 is connected to B1 and B2 connected to R1. So this forms a closed loop. It's the shape is like a delta. Okay, so three lines are Y and B. And even here we are going to discuss about what is the concepts of line voltage and line current, and phase voltage and phase current, and relation between those two. Okay, so here first one is, we'll list it. What is line current, what is line voltage, what is phase current, and what is the phase voltages. So line current, current through the lines. What are the lines are there? R, Y and B. Current through the line is IR, IY and IB. And whatever the line voltage, voltages between the lines R and Y, the voltage between the lines, which is VRY, and the voltage between Y and B is VYB, and voltage between B and R is VBR. And next, phase current. What is the current through the phases? If we see this, the phases are in a shape of delta. And if we see this junction, the current means the line is connected to this junction, and all the phases are connected in series. It means the current, we are going to apply KCL here, because the line which is connected to the junction and the current is different, and here it is different. So there is some three current across the junction, a single junction. Okay, so that's what phase current. What is a phase current? Phase current, which is I phase, is represented as I phase, and current across the phases, current in the phases. So what is the first phase? R, that is connected to Y, means the current between IRY, and current between Y and B, and current between B and R. And phase voltages. What about the phase voltages? Voltages between the phases. Okay, if we see the voltage between the phases, it's VRY, VYB and VBR, because R is connected with Y and Y is connected with B and B is connected to the R. So this is phase current and phase voltages. So what is the relation now between the line and phase, which is same? If we see the line voltage and phase voltage, both are same. Means we can conclude line voltage equal to phase voltages. VL equal to V phase. Next, line current and next we have to find the relation between line current and phase current. Line current and phase current. So what is the relation? Line current is IL, phase current is I phase, and relation we can make it as √3 into I phase. And what about the power? √3 VL IL cos phi. Cos phi is a power factor. And same thing, and there is a phasor diagram here. So here the relation is like IL equal to √3 I phase, means the two line current gives you the phase currents. This is about the delta connection. Thank you.